Good morning, guys. So this is my first video lesson. I'm going to start making just a couple really short videos that go over some of the different organic compounds we talked about before the break, because there has been a long time since you looked at that stuff, and it would be very reasonable to have forgotten most of it. So first thing I want to review is how the way we name or describe organic compounds depends on the number of carbon atoms present. Okay, so we use the number of carbons to give us a prefix that forms sort of the backbone of our name. It tells us what the compound looks like. And those prefixes look like this. If there's one carbon, we say meth, not math, but meth. If there's two carbons, we say eth. 3 carbons, prop. 4 carbons, bute. 5 carbons, pent. 6 carbons, hex. 7 carbons, hept. 8 is oct. 9 is non. And 10 is dec. Okay? And it's probably helpful for you to have a sheet while we go through this, and if you're doing any practice questions, it's probably really helpful for you to have a sheet that says these things on it. So it might not be the worst idea to pause a video, grab a piece of paper, and just copy this table out for yourself so you can refer back to it. Okay? So I want to just talk about some basic alkanes and how we might name them and what their structures might look like. So the first thing, we'll just talk about a name. Okay, and it says right here, alkane names end in ane. Okay, so alkane, ane. So I'm just going to pick one of my prefixes. Let's go with hex. And then if I add an ane to the end of that, that gives me the name of a compound, hexane. Okay, and hex means there are 6 carbons. So if I wanted to draw hexane, I could draw 6 carbons in a chain. 1, 2, 3, 4, 5, 6, okay? And then I can connect all of those carbons. So I'm showing that they're bonded to each other. These little sticks right here represent a bond between carbons, okay? The other thing that's going to be present in an alkane is hydrogen, okay? It's called a hydrocarbon. Just going to write that here. Okay, so it contains carbon, that's what makes up the backbone here, and then the rest of the bonding spots are going to be filled up with hydrogen. And carbon can make 4 bonds, okay? It always wants to make 4 bonds with other things. So right now, for example, this carbon is only making 1 bond. I'm going to add 3 hydrogens to fill up those other 3 bonding spots. This carbon right here is making 2 bonds, so I'm going to add 2 hydrogens to fill up its bonding spots, and I can just keep doing that. Okay, and then I have a structure. So this is a name, hexane, and then this is its structure. Okay, the last thing I want to show you, something that we have been practicing in class a little bit. It can get really boring to write your structures this way. So there is a different way to draw your structures that is a little bit harder to understand, but a lot faster to draw. It's called a skeletal structure. Okay, and that's going to just be made up of straight lines that show carbons, and then it implies that the carbons are bonded to hydrogens as long as it doesn't say anything else. So the start of my first line, that's 1 carbon. And then if I change directions, that represents another carbon. Okay, and remembering I'm drawing hexane here, so I need 6 carbons. So I've got 1, 2, 3, 4, 5, 6. So that's hexane right there. Okay, pretty straightforward. Okay, when we talk about alkanes, we can also play around with the shapes and the atoms present a little bit. So I want to go through two examples of that. Cycloalkanes, which are ring compounds. Then in a second, we'll talk about haloalkanes. So a cycloalkane, I'm just going to give an example of a name, a structure, and a skeletal structure again. Okay. But this time, I'm going to pick a different prefix just so we can practice. So if I look back at my table, maybe I'll go with pent this time, which means 5 carbons. Okay, so pentane would be just a normal alkane, like the hexane we just drew. But if I put a cyclo out front, then it changes the structure so that it comes back on itself. Instead of being a straight line of carbons, it's now a ring of carbons. So that's going to look like this. And you want to try to make it a symmetrical shape, but like drawing it symmetrically doesn't matter that much. Okay, so I've got 5 carbons, and because it's cyclo, I've got them in a ring shape. And then I just have to fill up the carbon so that they're all making 4 bonds, and I fill them up with hydrogen. So I've got a hydrogen here and a hydrogen here, and that gives that carbon 4 bonds. And then I just have to make sure to do that to every carbon, like so. Okay, and then if I wanted to draw a skeletal structure for this one, I could just leave out the explicit carbons and hydrogen, so I'm basically just drawing a pentagon. Like it's like elementary school geometry. Okay, and that would be the skeletal structure of cyclopentane. And then the last type of alkane I want to draw today is called a haloalkane. And this is where we swap one or more of the hydrogens in our compound with one of the halogens. So the halogens from the periodic table, they're group 17, they're fluorine, chlorine, bromine, and iodine. Okay? And they look, so the haloalkane would look something like, or might have a name like this. Something like 2-chloropropane. Okay? If I wanted to draw 2-chloropropane, the first thing I'm going to look for is the prefix that tells me how many carbons there are. Okay, and that's prop. And if I look back at my table that I made at the top, prop tells me there are 3 carbons. So I'm going to start by drawing my 3 carbons in a row. 1, 2, 3. Okay? And then the chloro here tells me that there's a chlorine atom somewhere on my propane. The number right there tells me where to put that chlorine atom. So I've got carbon 1, carbon 2, and carbon 3, essentially. And the 2 tells me to put the chlorine on carbon 2. And then everything else gets a hydrogen. Okay, and I'm already getting bored of drawing hydrogen, so you can start to see why a skeletal structure is maybe a helpful way to draw these. They're a lot faster to draw. Okay, so I've got 1, 2, 3 carbons. And then the hydrogens are always implied on the skeletal structure, but because I've got a different atom here, I've got a chlorine, I'm going to show that one. Okay, and that's it. Okay, so that is an introduction to alkanes. Okay, a review of stuff that we did cover before the break, but a little refresher. Thanks so much for watching, and I'll post some practice questions related to this if you want to give them a try.